Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. M. Jayasheelan, and he will speak on the topic complete biocontrol solutions for pest management and waste management in farming. I now request the speaker to begin. Thank you.
Okay, good evening all. Myself Jayasheelan. I have did my MSc Agriculture Entomology, and I have started in past 2018 my own startup, but now it has been discontinued for reason. Main motive of my startup is kind of a biocontrol. It's to end to end. It will be a IPM solution for the pest management with the insect, what we can do and how we can get benefited in the environmental aspect and it kind of a social aspects. So this is the main concept which is behind my motive to start the this biocontrol startup. So it's not about biocontrol. It's not about the kind only predator parasites comprises of all the micro macro organisms. So it's a kind of integrated approach which I am meant to have. An integrated approach is kind of a insects biologicals and kind of a physical traps and a natural repellents. So these are the kind of integrated pest management in a wholesome, we will tell. It's a very core component in our farming system. So let me go into one another. So this is the what we are going to have in a road map of this session. Means like we have some why importance for this biologicals. What are the framework? How what are the components of this biocontrol? Like predator, parasitoids, fungal, entomopathogenic fungal bacteria, nematodes, traps, etc. And apart from this, another component is called waste management through the biologicals. It's waste management, and a different kind of a waste management will be there. Either in kind of a microbes will be the major role play, but my main core play is with this insects, so that I'm dealing with this waste management through the insects also. And what are the global success stories which have been devastated in the globally using this in insects, biological insects, and what is the market, what are the landscape of this globally, and what can be the challenges will be there, and how we can be taken forward in the commercial. So these are the session which we are going to look into this. So before stepping into, so understood that like what kind of biological system is globally it has been covered up. What are the crises which we are been facing is around as we know that pesticides, which is our kind of insect killing only. It's kind of side is a killing agent. So around 50 plus of years, we are using only the broad spectrum insecticides. It's a broad spectrum. The term why I'm mentioning is a broad spectrum. It can kill whatever the beneficial. It doesn't know the beneficial insect or beneficial microorganism. Nothing. Simply, what are the living organism? It will be clear. It will be killed off. That is a broad spectrum. Either it can be a good earthworms also. So everything it will be vanished off. That's the how this we are been using the broad spectrum insecticides. So now specific insecticide, specific spectrum insecticides, molecular level, nano level, everything. Emergence of insecticides we have undercovered, but when we are going into the wider angle, people will use and they have been using this broad spectrum only. Around 50 500 plus insecticide ingredients which have been registered globally, that doesn't have any target specific. Some are target specific, most of the non-target to the living organisms only. So around if you see how much of the despite we are using pesticides, there is a post-harvest loss and pre-harvest loss. Everything will be there. It's accounted around 35,000 crores of annually. If you see the pest damage alone in India, so that interlinked with the pollination also. How it is being interlinked with the pollination means wider spectrum of pesticide. The reduction of this bee population also indirectly hit at a big massive things. So a solution is not like only the pest can be killed only with the chemicals. It's a myth. So in initially there is no chemical or nothing broader spectrum or narrow spectrum or target specific. Nothing is there. It's about the natural biologicals, how these natural biologicals meant to be into this ecosystem. So that it's a predator complex. We will be know that pyramid now. So there will be a larger group people, larger group organisms will be there that will be eating smaller group, mid group, and like microorganisms. There is a hierarchy of the food chain. So we have been disturbed these food chains, so which is naturally occurring. So now it pest population, disease, wider range of the microorganisms, which are the harmful things. It has been widespread, and we are finding out all high tech technological wise chemicals only. So though there have been advancement in the biologicals also, so merely that chemical is getting dominated in the market, not only in the market, in the field level also. So we are tracking with this framework of this integrated pest management, which is integration of all the pest management tactics, like to have a balanced productivity. Like if you see the environment, there will be a every ecosystem dealing with the food chain. So one another will be a predator only. So either a rat will be predator to the snake, snake will be predator to the birds, vultures. So this kind of a predator mechanism will be falling in every category of the ecosystem. So we mainly concentrating on the ecosystem, balanced ecosystem. So that's why in IPM even chemical control is a last option only. പക്ഷേ, like how we have to frame means we have to have a one frame, like first what kind of a cultural practice, whether we have been taking up into the pest identification, what kind of a monitoring activities we have been looking into, like we have to make kind of some traps or kind of a pheromone traps, sticky trap, light trap to ensure what kind of a pest activities are there. Then you have to go for the cultural activities, some kind of a crop rotation that ensures the crop stability, soil fertility, and the pest also, pest damage. So these things we have to ensure. Then third stage will be the physical and mechanical, like we are making the traps or some other alternate wetting and drying for the rice, or kind of a hand picking of the insects. So these kind of mechanical things also we have to ensure, or you have to burn off the old particles which is left over, so that ash will be retained in the soil. So these are the some small features where these practices in the held up with the IPM. So fourth component is a majorly we are dealing is the biological control. So already I have just mentioned that, like predators, parasitoids, pathogens, and beneficial nematodes. Nematodes is in the sense of beneficial nematodes. These are the microorganisms, micro living things, which micro, macro, whatever, it plays a major role in this IPM. So last option only, we are going for the chemical which is beyond the control. So if it is a locust, is a massive of the worm. So these kind of things that we need to make a sustainability. This is called sustainability integrated pest management. So sustainability, how it comes, like even kind of a chemical control. That should be not a broader spectrum. It should be target oriented. Target oriented, low toxicity, like green labels will be there, biological nano things will be there, not only the synthetic that have some threshold levels also. So those kind of a chemical pesticides or insecticides can be used in the IPM protocol. So after that, that is the decision making and records. So you have to look into the threshold levels, what kind of ETL will be mark placed. So based on the action thresholds level, you have to have a form documented, like what is the best activity, when it is been arriving, what stage it has been dealing. So these are the major IPM frameworks which we have to look into as a basic framework in the cultivation aspects. So before already I told now, these are the six frameworks which we are dealing with each individual components. So majorly we are going with this mechanical and physical traps, and this monitoring trap will be in the consist of six category, like pheromone traps, yellow sticky traps, blue sticky traps, light traps, fruit fly traps, like trap crops. These are the balanced in the ecosystem, which doesn't disturb anything, which whatever the pest which are been falling under the crops, it will be attract to that one on another. So it is a easy to catch. Like if it is a aphid, like sucking bacteria of pest, we will tell. So for that, yellow kind of a card sticky traps will be attracted. Some kind of a thrips will be attracted to the blue sticky traps, and pheromone traps, which is the synthetic lure, which is created from the different components of uh, pest of female. So those synthetic lure will be plugged in a rubber tube, so that can be released into the field. So male moths will be attracted and it will be captured in the trap. So this is one kind of a successful traps in the field mechanism. Like in IPM practices, this pheromone, yellow, sticky, blue sticky are the successful things. Light traps, when it comes to light traps, it attracts all the insects, all the kind of moths, all kind of a pest. It's not kind of a even we can't categorize it as a beneficial or non-beneficial. It will attract end-to-end insects because of the wide spectrum of light will attract to the broadest area of insects. So this will be operated only by night times, so that we can count the density of the pest population. Based on that, we can recommend, oh, this is are the insects are majorly covering up this field. So we have to ensure that these pest activities are being held up with this field. So we have to make sure of this biological or chemical or sustainably used mechanisms to control the pest management. Then, as fruit flies are majorly only concerned for the orchard crops like mango, cucurbits, guava. So that those kind of fruit flies which damage the fruits and the entire orchard gets the crop of value will be reduced. So for that, kind of a synthetic lure ethanol is being kept as a trap to attract those males, so that it population of the egg laying population will be reduced. So this kind of one mechanism to avoid the fruit fly attack damage in the fruits. And trap crops, like these also one of the main thing. Like so it's kind of a mechanism where main crop is escaped from the attack of the pest. So broader crop or the alternative crops, they will be planting the this alternative crops, kind of if example marigold, they will be planting against the main crop will be kind of groundnut or some other thing. So border crop will be attacked by the pest, so main crop will left as such. So the crops will be eaten by the sorry, that pest will be eaten by only the trap crops. So it is escape from the main crops. So this is how the escape mechanism falls as a trap crops. These are the six monitoring and trapping mechanism for the ecosystem for this IPM tactics. So next, coming into this biological, as we said, there are the three different categories. One is predators, another is parasitoids, another is entomopathogenic nematodes, and some kind of beneficial microorganisms like entomopathogenic fungi, bacteria. Those things also comes under the biocontrol only. So predator as a larger, as a macro organisms, we can tell these will act as a enemy for the insects like parasitoids. It will it will kill, it will squeeze those whichever the lively insects which is present in the field, irrespective of the non-chemical, non-toxicated non-toxicated field, these presence of predators will be naturally available. So as we see in this modern farming or high-tech farming, wherever the chemicals are sprayed in a vigorous manner, so we can't even find any natural predators which is naturally formed. So to attract the natural predators, they will be planting that all the attractant ornamental crops, so that these predator kind of redwood bugs, chrysophila. So I can show the images in later stages of the slides. So what kind of predators are available, what kind of parasites are available. So every target oriented, this kind of a predator will be target oriented for the this kind of some kind of a sucking pest, some kind of larva, some kind of aphids, some kind of so every predator has a or target oriented pest. So these are the effective for the field which we have been kept. So yeah, how much per hectare, how many beetles we can release per hectare, how many larvae or how many grubs we can release. So these predator will act there to reduce the pest infestation. So one of the successful is green lace wing, this top one, no? For mainly for the aphid, mealybugs, and severe infestation which occurred commonly in coconut. It has been devastated everywhere, widely in South Indian regions. So this green lace wing, there is no chemical, nothing we can't control over. So those white flies has been controlled with only this green lace wing fly, which is a successful biocontrol agent, we can tell. And so second category is the parasitoids. These parasitoids, these are the some micro living organisms. So we have a number of parasitoids. These how those things at all kind of it can kill and eat the insect. But the parasite kinds of things at all, it will go and lay the eggs over the insect. So it will develop multiple of eggs from the insect body. So kind of a Trichoroma chylonis, Trichogoma is there, Bracon triviconis is there. So Angrias, these kind of egg parasitoids or larval parasitoids or pupa parasite, three different kind of stages. Egg means the eggs of the pest, it will lay over that one and it will destroy the stage of that insect. The same thing Bracon. This Bracon breviconis, it is a special for the coconut larva. So it will lay the eggs on the body of the larva. So this is the kind of the parasitoids they will be saying. These parasitoids will be incubating their eggs in the body, host body of the pest. So host body of pest or host of the eggs, it will develop and it will further multiply, taking the nutrition of the host body of pest. So this is a special kind of a biological tool which is highly recommended in the all the rice, sugar cane, cotton mainly. So to reduce the sucking pest, mostly sucking pest and larval kind of pest is a general category we can say. And these are the what are the application rates per hectare wise. So a third category is entomopathogens. So entomopathogens is a wider category. In that we have the fungus, bacteria, and viruses. These kind of a microorganism will tell, like biologicals. These are the beneficial fungi which will destroy only the insect kind of. It won't cause any disease or spread of disease to the plants. That is the beneficial. Entomo means insect, pathogen means fungal, like a disease. So it will spread the disease to the only the insects, not to the plants. So it is highly beneficial to the plants. These category of pathogens are commercially utilized in the liquid form, formulated as a liquid. They will spray as a, instead of spraying the pesticide, they will be spraying, right? So instead of the pesticide spraying, they will be using for the different category of pest. They have the different category of fungus, bacteria, and virus. So larval kind are used for the NPV, these viruses. Bacteria kind is for the larva. The fungus at all, mainly this entomopathogenic fungal category microorganisms are mainly targeted for the sucking pest. This whitefly, aphids, mealybugs, thrips, etc. So different kind of entomopathogens are placed for the different kind of the target oriented pest. So beyond that pathogens, we have another category called entomopathogenic nematodes. These nematodes are same thing. It will kill only the insects, not the plant. So we have the pathogenic plant pathogenic nematodes, which causing the nematode, which causing the root knots, which causes damage to the all the root area of like a potato, whichever the root grown crops at all. So this is beneficially target oriented to the grub stage of the insect. So how it works, you can see this five stages. Infected juvenile stage seeks insects host in the soil, because nematodes will be target oriented only. It will specifically go and kill the worms or the larva or the pupa or kind of a soft body to enter into that body, and there it will multiples. That is the main, so that insects gets killed off. So host dies within 24 to 40 hours of the infestation. Why? How it will means, it will release some symbiotic bacteria. So where that bacteria develops into that host of the insect, and it will killed off, and where again these nematodes will be developed further. So these entomopathogens develop further, so that host of different insects will be killed within 24 hours to 48 hours. That is a main result oriented, which we I have practically seen as entomopathogen nematodes as a successful story. If you see, for cardamom, I have when I worked in the Idiki districts of Kerala, cardamom faced a severe issue of root grubs. Root grubs are under the root area. So I have released this entomopathogen nematodes into the soil root area in the form of cadaver, and the insect cadaver. Mm, it's shown 100% result. Within a next day, we can see that all the grubs are died, and it causes the redness of the grub, and later it formed as a cadaver and died. So it is one of the successful pest management in the for the root grubs, root soil area, not like aerial spraying at all. There are a lot of recommendations in aerial foliar applications at all, but if it has been target oriented only, it will kill. If it has been if insect is not placed in that if it is not in contact in action, it won't take up the further action. So best is entomopathogen nematodes will be worked under the soil only, not above the soil. So another you have seen that as a three things. One is the trap mechanism in the IPM. Majorly these are the trap mechanisms, and the second is this predator, and the third is the parasites, and fourth is this entomopathogenic fungi, bacteria, viruses, and fifth is the entomopathogenic nematodes. These are the main core of biologicals which we will deal in the farm to maintain this ecosystem, to maintain that ecosystem, like to bring back that food chain in a consistent mode. So these will be helpful for the making the farm into the better practices. So apart from that things, we have the waste management through biologicals. There are, as you know, there are different kind of waste management. Like one is for through the microbial. Okay, these are the aerobic decomposition, they will be tell, like kind of acetobacter, there's a kind of a potash solubasing bacter, phosphorus solubasing inoculum. So these kind of inoculum will be sprayed in the waste, food waste or kitchen waste. So it will decompose, and it can be that decompose can be enriched as a compost, like a manure compost. So third is like trichoderma. It's a trichoderma based also. It's same thing. This will be sprayed over that compost. So it will suppress all the other bad microorganisms. So it will decompose further within 45 to 60 days, and it will form as a at the end product. If you see, all the waste of kitchen or fruits and vegetable waste turn into the compost with the help of some media. So that media only we are choosing as a either vermicompost or kind of a microbials or kind of a trichoderma. So the fourth concept is black soldier fly. It's a kind of an insect. It's a very wonderful separate concept. It's a detailed thing. I can't brief within limited time. We'll see in next if any opportunity is there, I will continue separate about this black soldier fly. So this what will do, this larva will start eating the all the organic waste. Its main food is waste only. So this larva will feed on the organic waste, and it will convert, it will reduce that biomass of the one organic waste. What will happen that all the waste will be flickered out as a manure. So then the adult, it will lay as a pupa, and then it will convert as a adult. So adult flies is a non it doesn't have any string, it doesn't have any public nuisance creating like kind of a insect. It is doesn't harm to the pest, human or even domestic also. It's a very just it will breed, and it will eat honey or water solution for the egg laying alone. That is how the adults will be. That to 1 or 2 days it will be after the egg laying. The adults will be killed or it will die off. So main thing is what it's not about the vegetable waste. Whatever the organic waste, even if the fish, chicken, what kind of organic waste it is, it can decompose, within shorter time, 3 to 4 days, and it will all the frases will be materialized as a compost. This is one of the exclusively proven thing also, which I have been directly dealt with this black soldier fly. So these are the success stories in biocontrol action. If you see for fall armyworm, it's one kind of a devastating pest which it has been created a tremendous tragedy in the maize. So for that, they have been recommended telenomus and trichogramma parasitum. So where it has shown the success result also. For every targeted pest, we have the targeted predator or parasite. So it is also proven also in a recordic manner. So these are the success stories. Apart from that, how the markets from past 2024 to this 5 year markets exclusive for biopesticides. If you see Indian market size around 4,500 crore, the value these biologicals have been embedded, and projected market also will be around 12,000 crore. So that much of demand export related things are dealing only with this biological, because if you need some kind of a produce as a organic or to be certified, only this biocontrol plays a major role. So the value of a premium value of a commodity, irrespective of a commodity, even it is a spices, even it is a vegetable or fruits, a produce normally conventional method, you will spray like a chemical spraying, etc. But the same crop per kg, the same commodity or whatever the crop you are being selling to the market as a if it is a tomato or kind of a brinjal, whatever thing, so you are selling per kg of 20 to 30 rupees. The same market which you have been using with the biological or organic practices, or this kind of all the IPM practice produce coming out as a output product, will be sold as a premium product as a per kg to 100 rupees. So that is the demand in the globally. This biological also plays as an input player. Around 35 plus state biocontrol labs are there in our India. So apart from that, there are a lot of policy-wise supporting mechanism in our India, like a National Mission on Sustainable Agriculture, which promotes biocontrol, biofertilizer, and RKV Raftar. So they promoting the biological lab and input labs, agri startups to handling biocontrol firms. And third is zero budget natural farming. Majorly this Andhra Pradesh model, they have been promoting over 6 lakh hectares, and the PM Kishan Samriddhi Kendra. These also involves for the bio inputs to be a mandate thing. So this kind of a number of policy regulations are all already dealing with our in India landscape. Coming to the challenges and way forward. So what makes this major challenges is when it comes to the predators and parasites and even entomopathogenic nematodes, right? Like if you see that entomopathogenic fungus bacteria, it can be stocked and stored in a liquid item. So that majorly takes place as a, 6 months or to 8 months as a shelf life. Sorry, let me see, show this one. So, major problem challenges we are facing is a shelf life for the predator parasite, because it's only a field application we can do. If we are been preparing a egg parasite or some other larval parasite, we have to immediately release to the field. That is a major constraint. We can't even shelf it in the rack. So, lack of cold chain infrastructure and slower kill pesticides, inconsistent in the efficacy for the temperature, limited awareness for the correct application methods, mainly explicitly for when farmers dealing with these things at all, and commercialization bottlenecks, because this biological, except the biocontrol liquids, if you see in the market, you can see a lot of the liquid only. Liquid spraying, this biomechanisms, biocontrol fertilizers, biostimulants. These are a number of markets product producer there. But sure, when we come under with the category of these predators and parasite, very limited, very limited. There is no commercial category of predators and parasites or production in India. Maybe very few in the field level biocontrols they have been dealing, and they have been releasing to the farmers based on the order pre-order. So this, and there is no regulations also, policy regulation for the exclusive for predator parasites. So what, keeping with this challenge, what can be the way forward we can look into means, like main thing, this can be granulated. In earlier I told no, micro encapsulation can be done for the entomopathogenic nematode. Instead of live insects, we can take it as an encapsulation, so the shelf life also will be extended for the 1 year. Like FPO level biocontrol should be encouraged, so that will be the faster solution for the farmers who are dealing with the 500 to every FPO level. This biocontrol unit is established. So the in addition to the chemical pesticide, they can have the alternative sustainability of usage. So the farmer can train, so they can make the IPM practices. So cost of input chemicals will be reduced, they, because these are can be owned, they can rear by their own, they don't need to go with the other external hiring or procurement at all. So these kind of integrated pest management dealing with the farmers can be encouraged through the FPO concept, who's already dealing with 500 to 600 farmers in a single shot. So these can be easily applied and they can be trained, they can own produce their own biologicals, and they can be distributed to their own farmers. So there brings kind of a support system. So if even funding mechanism can be dealt with the NABARD, so some state biocontrol things, they can be getting funding and some policy level support mechanism through the government. So these are the main challenges and the way forward which we can project further this biocontrol in the IPM. So these are the things. If anything required, I will discuss later for the elaborate things in a different way. There is insect relators or also is there. So let me show some other images of.
Okay, you're
Uh,
done with the presentation, sir?
Yeah, I done with present. Just I am showing this. What are the kind of this is the overall chart of the biocontrol agents, entomopathogen and entomopagus, like predator, parasite, and what are the parasitoids, say larval pupa, and what are the predators, and what kind of entomopathogens, virus, bacteria, fungi, and nematodes. So these are the redivits. These are kind of images of coccinelles, predatory mites, chrysophytes, and what kind of a recommendation. And these are the parasitoids: trichogramma, bracon, calinomus, telinomus, chilinos, and some kind of a fungus, entomopathogenic fungus. So these are the nematodes, entomopathogenic nematodes, which are the beneficial nematodes. So this is, I told you initially, these are the infected cadaver. So this from here we will be applying to the field, so that it will be released, the nematodes will be released, so larva will be infected as such. And a lot of biopesticides are there, bacteria, metarhizium, verticillium, that kind of commercial pesticides are there, biopesticide. And these are the successful stories. And everyone knows that advantages will be ecologically balanced, environmental safe, broader sector, it is target oriented, non-toxic to human, no contamination for the water and ecosystem. So we have seen that major challenges also. So considering with the major challenges, I am concluding with the this use of biological control in pest management will be long, and it's environmentally friendly, and it will be the wider research for the future for to improve the further advancements also. So, okay, thank you.
Okay, thank you very much, sir, for a wonderful presentation. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir, so
Sure.
that we can see your full video? Yeah. I'll move to the questions now. The first question is, what are the major challenges farmers face while shifting from chemical pesticides to biological pesticide management?
Major constraint is means see, it should be like a ecosystem. Ecosystem means it's not like a, if there will be in a village or in a kind of a block, there will be around 100 to 200 farmers, they will be doing a cultivation with a different crop. So someone will be in a some neighborhood field will be cotton, some other field will be sugarcane, someone field will be groundnut, or someone will be cultivating vegetables. Some part of the farmers will be encouraged to do the chemicals, some part of the farmers will be doing the organic. So what the major drawback means, even though they have been doing dealing with the organic things, the opposite side of who is being spraying like other field neighbor farmer field, so those pests will again will be increased to the organic field only. So what is the major constraint? They are not get promoted for the organic cultivation or dealing with this biological practices. So it should be a community base around 5 to 10 kilometers of all the cultivation should be dealt only with the organic. Then only this biological step will be forwarded, or else the farmer who is being dealing or interested to keen into the organic cultivation also, they'll be facing some issue, like they'll be again the pest infestation will be severe, so they will again go ahead with this chemical. So major constraint is, first of all, entering into this biological is neighborhood of the cultivation should be in the organic way. So neither the neighborhood of the farmer or nor the this own farmer, both are dealing with the organic only, they can step into this cultivation like a biological, or else it is very risk to the farmer who is entering into the organic cultivation. He will face severe crop loss to the from the beginning stage itself.
Okay. Can biocontrol solutions be integrated with existing farming practices
Yes, yes.
without affecting crop productivity?
Yeah, like see, there is a crop calendar is there. Timing of the spray application, when to apply the pesticide, when to take up further action for the next. If it is being from nursery stage, there is a duration. Okay, so after 10 days of the harvest, so after sowing, so after 30 days of the transplanting, some kind of a chemicals you have to spray that. But in between, you can take it. You can't. You should not directly deal with the chemicals. First of all, you have to go with the cultural practices. So you have to see whether what kind of a infested. See, it's a nursery now. So I'm saying with the starting stage itself. It's a nursery. So nursery stage itself, you have to take it for the cultural practices. A clip of the what are the infested pests that can be hand removed, or what kind of a trap you can set up. So those monitoring mechanism, cultural practices. Then you go ahead with the biological, like spraying with the bio entomopathogens or entomofungus, whatever kind of a spraying you can spray. Alternately, you can release the predators and parasitoids, so where you can find the sustainability of the ecosystem in the cultivation. Then if the infestation will be the threshold level, there is always a threshold level. So you have to see whether the threshold level for every pest is beyond 50% or beyond the 30%. There is a every pest we have one ETL level. So based on the ETL level only, we have to recommend the chemical. But farmers, what they're doing, if they're seeing one or two pests, also they are recommending full dosage of pesticides. Recommending in the sense either from any aspect, even from the chemical retail shops or even by nearby, there comes the lack of awareness. Okay, so extension activities from the department sides of who has been dealing with the thing. So initially they should never go ahead with the chemical spraying. First they have to look into what kind of pest they have been analyzing, whether it is a truly enemy pest or it is a beneficial insect, that they need to recognize. That is the monitoring mechanism they will be saying. So first, based on the monitoring only, which kind of insect is came into our field, what kind of a mechanism next we have to. There should be a knowledge based on the what are the beneficial insects and what are the harmful insects. Then only they have to go with the chemical spraying. So people they are thinking if you see the pest, they have to spray the chemicals, so then it will be controlled. They are thinking okay, if we spray the chemical it will be controlled. No, it is the chemical process is not a killing process, it's just a knockdown effect. Okay, so sometimes over the period the same spraying of the chemicals will make the insects to resist sometimes resistance will be happening. So resistance, sometimes it won't affect anything, but resistance it creates, it will develop further secondary pest also, like mites. It will be invading other pest also. So we should be very careful while dealing with the chemicals. First of all, we have to go ahead with biological. We have to take the monitoring steps, traps or other things at all. Then you have to go with the little spraying of the frequency interval. So if already existing, they are dealing with 20 days, 25 days of interval. In between days, you can spray the biological. So every biological spraying has the residual effect of 10 to 15 days. Even if you have sprayed, another question you can say, like if you have sprayed today, the day one you have sprayed the chemical, it's about some there has the residual effect. Every chemical has some residual. If now nowadays that residual effects are only 2 to 3 days only maximum. Target oriented, specific oriented pesticides we are nowadays we are dealing it. So that we should ensure that green labeled or yellow labeled is uh, sustainable for the chemical spraying. After that, 10 days or 1 week later, you can release the predators or parasite. Either pre or post, we have to have the time interval between 10 to 15 days of the pre and post application of the chemicals to release this biological or release the biocontrol thing. So even biologicals also will be sustained in the regular practices. Meanwhile, we need an interval time between 10 to 15 days for whatever application.
Okay. Sir, what are the most commonly used beneficial insects, fungi, or microorganisms in biocontrol?
In commercially, if you see, rather than the macroorganisms like predators and parasites, microorganisms are the globally, even to the till the village level, people knows entomopathogenic fungus and entomopathogenic bacteria, like kind of metarazium, verticillium, then kind of a bacillus. This kind of liquid biologicals are commercially available, and they have been widely used for the insect control. And it also showing a result because it has a shelf life also. So people can easily spray as alternative to the pesticides, chemical pesticides.
Okay. Sir, how should farmers identify the right stage to release biocontrol agents for maximum effectiveness?
See, there is no right stage. We have to keep the ecosystem sustained. First of all, as currently this stage, the environment, current environment, we doesn't have any predator or parasite population. So there should be a naturally those insects will be attracted when it is the field is not even infested with any chemicals. If the chemicals are not there, naturally these predators parasites will be falling. So we have to develop release simultaneously this commercially we can buy lot of trichogramma parasites are there, predators kind of green lacewing will be there. So these can be released frequently to maintain the ecosystem. So this will find themselves to sustain in the field. It will go and find wherever the pests are there. It will go and kill, it will trap that, it will parasitoid those insects eggs on the body of the pest. So this mechanism will be very well happening only if we release frequently over the field. Why? Because I'm stressing frequently means, if you see example mango, there are in a shop there will be different kind of variety of mangoes will be there, and quite yellowish, full shiny at all. So these are fully chemical treated. Okay. So there in that shop on that different variety of a mango, bright color, everything is there. Even a single housefly won't go and touch that fruits. It won't go there to taste that fruits. But same organic cultivated fruits which will be in a dull color, okay, it won't be in a bright yellow also. This is a sort of example. So that they have never touched any chemicals. There you could find that organic mango. So where the houseflies will be crowded in that mangoes. So this is the best example where how naturally predators will be falling or attracted. I told no attractant. So without the chemical only, all the predators, parasites, or kind of things will be attracted. If it is be chemically treated, even it is a bright or shining or good looking also, these predators, parasites won't come into that field or that fruit. Why? Because means it is that they have some sense to for the chemicals.
Okay. Sir, how long does it take for biocontrol agents to show visible results compared to chemical pesticides?
Visible results, it takes years. So it's not like a chemical industry is a very globally widened thing, and we can't even compete it with the chemical as showing a within a day, within a week of results at all. So if you want to have a healthy and sustainable output of the produce, it takes a years minimum. On conversion of things also, while or inorganic to organic conversion also, it takes 3 years minimum to make a healthy output.
Okay. How can agricultural waste be converted into a valuable resources using biological
So
method?
biological, since I have shown now, there are four different kind of methods. So one is microbials, one is a vermicompost, another is kind of biofertilizers. Fourth is the insects. It's kind of a black soldier fly larva. We will be telling commonly, but these things at all, it is has a n number of output. This larva, what will do, it will eat end to end whatever kind of a waste, organic waste, even vegetable leaves, fish, meat, rotten, whatever thing which is organic, it will be converted, it will be eating, and it will be converted as a frass. The leftover frass that are as a fertilizer, it can be used. Those insect, right, that larva can be utilized for the feed for the fish, poultry. This is also proven thing. So multi usage of waste management can be dealt for the agriculture system is uh, this black soldier fly larva. It's a already proven thing. Commercially in Salem district also they have been doing various in Coimbatore. You can see Star Agro, some BSFL. So they are dealing in a commercially. In every state, they have been different kind of a black soldier fly, like a waste management for the agriculture. Not only waste management, it's a kind of a waste come wealth. So how it comes to wealth means the end product will be used for the compost. That larva can be used for the feed for the fish, highest protein than comparing with any other protein source.
Okay. Can farm waste management also help reduce greenhouse gas emissions and improve sustainability?
Mm, farm waste, yeah, we can use farm waste. It is a commercially they are dealing with the biogas. So if you see as a biogas unit at all, these farm waste will be dumped in that bin, and that will be decomposed naturally. The gas which is formed is been taken out like a cow dung, mixture of that farm waste residues, whatever left over in the field. They will be developed as a doom based biogas unit. So that will be dumped once after decomposition. That gas of methane will be formed, and that can be used for the kitchen purpose. This is one kind of a method. It's been from years on years they have been dealing, and that is a one kind of a farm waste management and commercially utilized as a biogas.
Okay. What kind of return on investment can farmers expect by adopting biocontrol methods?
Oh, return on investment. See, when you talk about the return on investment, Either already I told, no, it is a premium kind of a produce. So when you're dealing with the organic thing, it's kind of a biological or kind of integrated pest management with the zero chemical. IPM, it includes chemical also. When it comes under the zero chemical, fully of biological, fully of predators, parasites, fully of only organic spraying, you can get a premium value where that if it is been you're spending 50 rupees for the input expenditures, the output will be product is a commercially if we see 100 rupees, 75, sorry, 75 rupees per kg. Okay, you have spent for that entire per kg of output, the chemical or biological at all 50 rupees, so profit will be 25. But when you go with the premium of a sale of the product, when it is been certified by USD or gap certifications, the value increased to thrice. So thrice in the sense, certified it includes as a like kind of a 300 rupees. This is how the returns of the investment ROI factor dealt with the fact what are the inputs they have been dealing with, what kind of a process technology they are taking up, and what kind of a market they are dealing with. So even if they are dealing with it, kind of a world IPM solutions or the biological. So where the produce being sold out, that is the value of the returns. See, same crop, same thing, same A farmer is dealing with all the inputs of the B farmer also. Farmer also, the A and B are giving the same inputs only, same biological, same pest, the traps mechanism, monitoring, same thing only. But A farmer is done with the certification process, so they are dealing with the certification process, extra care, extra process technology. B doesn't follow any technology of certifications. So the produce of A and B are the same, but the value of returns is for the B who follows the certification of organic thing. He gets a premium value. A will be getting the lower than the premium value, but not as a commercial value.
Okay. What are the most common mistakes farmers make while using biocontrol products and how can they avoid them?
Hmm, biocontrol products, there is no limitation for the dosage or usage at all. Even if you're beyond the dosage, commercially, if you see, 10 ml per liter is a basic formulation, 5 to 10 ml basic formulation to the spraying per liter of water, irrespective of a biological. Even if it is beyond the dosage at all, it doesn't affect, first of all. Over the dosage, it doesn't affect. That is the term in biological. It's a, because it's a living thing. It can exhaust, it can deprive, whatever it can be, sustained. But when you go with the chemicals, there you need to consider what the term you have been mentioned as a correct dosage will has to be figured out only in the chemical only, not in biological. Biological, beyond the limit also it can be self-sustained. For sure, if the point 5 ml of per liter is a recommended dosage, if a farmer goes beyond 0.75 ml also, there will have a severe issue in the lethal effect of the plants. Sometimes plant will die drying, lot of things will happen. So knowledge to be taken place only dealing with the chemical when they are spraying. They has to have the knowledge on awareness, extension activities, end-to-end things should be dealt only through the kind of chemical spraying, chemical dealing only.
Okay. Are there any government schemes or subsidies available to encourage farmers to adopt biological pest
Yeah,
management?
like natural. See, there is a national scheme, natural for mission on natural farming, natural mission on natural farming. This is a one kind of a scheme where every state they have been adopting with kind of a respect to that village level, block level, through the departments. So they encouraging, they give the subsidies for the biopesticides, biofertilizer to the farmers to encourage that one. So those one of the central government scheme. Other kind of already have told a lot of RQI. So if they want to set up some biocontrol, so training also is there available when you go with the NIPHM Hyderabad. So you can for farmer trainings there is a kind of a agent institute. in-house training for 15 to 20 days, or even for 1 month also you can stay there. Based on that, they will be giving all the kind of modules, how to cultivate, how to grow, how to make for a on farm biocontrol agents at all. So that kind of supports at all central government are encouraging.
Okay. Sir, what advice would you give to agri entrepreneurs interested in starting a business in
Yeah.
biological crop
Uh,
protection and waste
mm,
management?
yes, of course. So being initially I was being an entrepreneur in a startup for this biocontrol. I've been awarded young entrepreneur also in 2018 with various aspects in FPO, farmer angle at all. So being now as a young entrepreneur, they have to focus for the integrated farming only. It's a kind of a good startup in the sense, in future, nowadays people and youngsters are more seeking agriculture, like kind of farming, even not even agriculture, youngsters, even work employees of IT sector, they are living their high paying jobs, they are entering into this farming. So farming is not like a commercial. They need to make the sustainability of the farm, kind of chemicals with chemical free, pesticide free food. So they are bringing lot of awareness mechanism. So people, youngsters should have to make into this opportunity, so they can bring this into the commercial also. These are the farm level things. So there is a scope and opportunity who are been dealing with the organic cultivation. We can supply this kind of a biological, this kind of a predators, this kind of a pesticides, biopesticides, this kind of waste management can be done. So we can deal waste management is a big concept, it's a separate concept. Tons of waste, or per day itself we can't even government is facing a lot of technology to fail it out. So we can collect the waste and we can convert those waste into this insect, and insect can be sold out as a good product. So highly commercial profitable business, this insect farming.
Okay, thank you very much, sir. We have now completed the round of questions on behalf of agricultureinformation.com. We would like to thank Mr. M. Jayasheelan for the talk and for answering the questions. This meeting will now be closed.
Thank you.
You're most welcome, sir. Bye bye.
Yeah.